Good afternoon and welcome to Thursday afternoon sessions here at the Next Gen Train Control Conference in Philadelphia. Our next speaker is Phil Dubery, who is the co-owner of CPC Systems in London. Phil's on vacation this week, so he couldn't travel to present in person. And so we're doing this as a Teams call, and hopefully the time lag between Phil and I is not too bad. Unusually, Phil's actually in Vancouver when we're recording this, and I'm in Toronto. And Bill in the background, who's going to be doing the editing, is in New Jersey. So this is going to be an interesting experiment in timing, if nothing else. Phil, we can put the deck up. You'll see Phil on the left in this first slide during testing for the Elizabeth line. We heard from Mark Wild last year. What you probably can't see very well is that Phil's wearing a mask, and it shows you the environment by working in during testing. There you go. And on the right-hand side, you'll see a young Mike Palmer in the middle at the bottom in the centre. And just above me to the right is Phil on the same trip. And then if you move left 3 people, you'll see Sid Bamra, who spoke last year. And if you move left again, you'll see Walter Kineo, who was also on the same trip. So it's a bit of a small world for some of us, but it's I wanted to share that I've known Phil 20 years and we've worked together on projects. I've hired him, we've worked together. It's just been an amazing time. So Phil, can you introduce yourself and then launch into your first slide?
So briefly, I started on the railway 40 years ago with London Underground, worked across all aspects of fleets, so everything from new builds, refurbishments, operations maintenance, and sort of really at the sharp end. From that, moved into the main upgrades, which was train signals control, track and power, really pulling together the service enhancements on the underground. And then after that, for sort of the last, as Mike says, probably 19 years have been sort of at the heart of bringing in modern railway systems, so CBTC systems, all the moving bits of the railway, really, trains, signals control, and all the movements associated and with PSDs.
Great. So if you go through your slides, I may cut in if you see me kind of indicating where I think it's important. Otherwise, I'm going to try and keep quiet until the end, which is a feat within itself.
Okay, thank you, Mike. So started with Crossrail. Mark Weil gave an extremely good previous interview to this group. I started early 2019, which is when the railway was due to be in service, and really my role since then has been getting the railway into a fit state to enter passenger service, and then supporting the reliability growth since then. Very much at the sharp end in the control room with the operators and working through with the both the MTR, the operating company, and RFL, the infrastructure company. The Elizabeth line, as Mark described, is a challenging line. It's an extremely important line for London, as with the S-Bahn and with the RER in Paris. It transforms travel in London by having a mainline size train come all the way in from the outside of London and actually run directly through the heart of London, so people don't need to interchange at terminus. And in order to achieve that, we have at each end running with mainline network rail signalling, which is AWS TPWS, through the centre running a Siemens CBTC system with full ATO at approaching metro style frequencies, 24 TPH. A couple of particular areas that we have challenges with, which are we have 2 permanent transition boundaries coming in and out of the central area. We have platform screen doors, and we have a first application of auto reverse on mainline at Paddington in the centre in order to enable the capacity.
And at Heathrow?
Heathrow, we have again, at the moment, a permanent migration boundary between ETCS and TPWS AWS, which is the mainline system. And shortly, in a few months' time, from Acton mainline to Hayes and Harlington is also due to switch over ETCS. So our migration boundaries will move slightly.
Wow, so you're doing migration on the fly at 2 or 3 locations in one single trip with all the onboard equipment and the wayside.
Yeah, so, up to 50 miles per hour, yes.
Wow,
yes.
Okay, that's a challenge. Okay, thank you.
Okay, the way the line was introduced, there were due to be 5 stages, basically bringing in the Great Eastern, which is the bit at the east of the line, then bringing in the Great Western, and then bringing in the Central. The Central started off by running as standalone. There was going to be a stage 4 with just the east coming through, but we actually moved, as does tend to happen with projects, because of where the project had got to, we moved straight from 3 discrete railways operating into stage 5, which was complete through running of the line. What it did allow us to do is got a lot of bedding and improving in the central section before we actually exposed it to what was already 2 live passenger operating lines. In terms of reliability growth, I think the biggest thing for me about reliability growth, it's all about culture, and it's all about starting early. You've got to start with understanding the railway and get right in at the beginning of, well, design, proving, but dynamic test on the left there, that's me with the one of the Siemens testers in the control room, and basically got in with them and understood they were doing the test cases, but there's a huge amount you can learn about the railway during those test cases, which if you understand and preempt early, helps you get to the following system proving and revenue service a lot more effectively. The next box, we were basically, my team was given 4 trains which we could run around during testing. We'd put a closed circuit timetable to stress the system as best we could with 4 trains, which culminated in us then in December 2020 with MTR real drivers driving and RFL real traffic managers signalling the system. We were given 8 trains. We wrote a timetable to run them close together to really stress the system. Took out recovery time to get the maximum possible operation, and we ran 12-hour days, 8 trains, and really the aim was to bust the system, to see what happens when you really push and drive the system. That gave us the key operational and technical improvements we needed to make to enter trial running and revenue service. And the boxes on the right, basically we kept on consistently rigorously monitoring and improving the railway throughout those stages, and we're still doing that today to drive up the reliability.
So in the description in the agenda, I describe this as open heart surgery. It's great, all the stages building up your confidence with 4 and 8 trains and then going into trial runnings, but you're still doing this analysis now to further improve reliability?
Constantly. We've got, and I'll come on to, we have a really good relationship with the trained operators and the signal and control staff, and with Alstom for the trains, Siemens for the signalling, and Norbrems for the PSDs, our main assets that we interact in systems, to constantly drive up the performance. And it's you just can't take the pressure off. You just got to keep pushing all the time to get the performance up. So if I sort of explain a bit about how we did that, this is SIDT was the system integration dynamic test. So that was our first real ability to drive the railway. What we did, we took the recovery time. On the left, you've got 1 to 11 it's just Paddington to Abbey Wood, which is a round trip in the centre. So by taking the recovery time out, we could get 11 round trips per train per day. We started with 4 trains on the 3rd of December, and by the 8th, 9th of December, we'd built up to 8 trains. By writing a bespoke timetable and putting the trains really close together, we really drove the junctions, we really drove the interactions between the trains. And a lot of the time, green is good. We were running, within 5 minutes. So for a system that we were proving, it was doing fairly well. What you can see is when things went wrong, which is when the colour changes from a yellow to a rather alarming pink or red, when we've got a really long delays in, we found a lot of domino effects. So we drove out individual failures, but the other thing we found is the domino effects, where once one thing had failed, other things started failing behind as the trains were coming together and as the junctions were getting stressed. And for everything that we've got a number on there, which is in white, for those highlighted, we basically dived into the diagnostic logs to understand exactly what had happened operationally and technically, and what we needed to improve to get into revenue service. What that looks like at the end is, as the lead for it, we really thrashed that system throughout December. And what we came out at the end was we had a number of things which were broad system type issues, which I've put as general on the left here, and a number of things that triggered on specific sites. And so we could come out and we could be really clear. Here are the operational things we need to address. Here are the technical things we need to address. Within that, we also had a lot of actually asset failures that we were driving up the reliability on. But we came out at the end of the month with that really clear view, which we could share through this with the operators and with the technical people about, right, this is what we need to do if we actually want to launch our revenue service.
So you've got the line there, the central core of the line from Abbey Wood on the right, the migration back boundary at Stratford, and then you've got Paddington on the left.
Yes.
The numbers relate to an incident, so you can see clusters of incident, but there's a lot in the Paddington area. If you take your general issues and your specific site issues, can you pick out a couple? It's a busy slide, I'm afraid, everybody, but if you remember what Phil now picks out, you'll see the entire list much better when you get the deck to yourselves.
So there were things that hit us that frankly we weren't expecting. We'd been running 4 trains. We had things like head code entry issues. So when the drivers open up the trains, they have to have a valid head code for the train. So the head code setting the destination and details of the train trips. What we hadn't realised is during our four train testing is they'd been using dummy head codes that are used for testing. So when we went to start doing this, suddenly we had lots and lots of delays because drivers couldn't get head codes in. Actually, it had implications further on because what we realised is for the normal timetable, there's a big integration between the signalling and the trains. But where we'd got contingency timetables set up for possible failure modes, they all needed to be in the head codes as well. So there was learning lessons there. System-wise, we had things like there's a steep gradient going up into the turnbacks, the reversing location at Westbourne Park. We were trains who were losing positioning. When they lost positioning, it would flag as a non-localised or non-positioned train in event section. That would cause the following train to stop short, and that would cause the following train in the platform, and that would cause the following train to flag a technical SPAD because of positional uncertainty beyond a markable, beyond a signal. So those were the sort of domino effects where we could see if we had these in service, it would really impact being able to run a train service.
So on the right hand side there, halfway down, you've got a silly one, rear cab door open. Is that just drivers forgetting to close the door and auto turn back or something? As simple as that.
So we had a bit of a combination on that. So we did absolutely. We had some where it was simply a rear cab left insecure when it should have been set up ready for changing ends. Some where the rear cab door was not closed. Some that we found where the door interlocks, the door needed really good slam for the door interlock to make, so what the drivers could see, the door was closed, but actually the interlock hadn't made it and they wouldn't know that. So we were picking up things like that where, again, for an operational service point of view, it's a 200-metre train. It's a long way to go back and reclose the cab door in service.
So what happens next?
So after that, we fed that through into the technical improvement process. We fed that through into the trial running. So we had a period of trial running, and then we kept working with the operators, driving those improvement programs through. And the other thing that we did during that system proving, we basically pulled all the central logs and we ran a railway performance dashboard. So we looked at the interstation run times and the train profiles, and we saw that in a number of locations, the trains simply weren't running properly between platforms, and that was during recovery when we wanted to recover time. And of course, the 2 parts of reliability, one is avoiding delays coming in, but the other is getting your time back again. So we went through that and we actually managed to improve a round trip time by 2.5 minutes just by dealing with all the locations where the trains weren't reaching optimum run times. We dealt with things like there was a delay on door closures, which was impacting each platform, only a few seconds per platform, but when you're trying to recover a railway important, and we dealt with areas that were infecting throughput. So we did both the dynamic proving to drive the initial failure modes, but we also went through all the improvements we could make to help recovery.
Okay, and how about other KPIs?
So other KPIs we had for things like, well, for the rolling stock signal controls points, we looked at things like point throw times. We did quite a bit around PSDs, which I'll come on to, platform screen doors, because we had some interesting effects on the platform screen doors with no passengers. But because the screens on the Elizabeth line are full height, the tunnel is sealed, we were getting a lot of effects when the trains were close running, with the pressure from the trains affecting the ability of the platform screen doors to close.
Okay, so we've got about 4 minutes left before we go to questions, Phil. So if you can show us that.
I'll move quickly on. So the other thing is performance review. This is something, a discipline we've had every day, which is with the operators, train operators and signal and control staff, and with the suppliers. On the right is basically, that's a full service day. That's all of the trips on the x-axis and the time of day on the y, and we rigorously go through every single event operationally and technically where we have a delay, which is anything that's in orange and red there, to understand why it's happened and how we improve.
So what's really impressive about that slide, Phil, if you just go back a sec, is the fact on the left hand side there you have 5 companies. MTR had the concession to operate. Transport for London is the infrastructure owner, including Rail for London as the maintainer. You've got Alstom with the train, Siemens with the signalling, and North Brems for the PEDs. The collaboration and cooperation had to be spot on, so there was no finger pointing or anything else. But it looks like you cracked it.
Yeah, we did, and Mark said that as well. I mean, it really was good. Everyone had the right mindset of we're just going to get this railway working properly, and at the working level, we're not involved in any of the commercial, political dispute. We're just, what do we need to improve the railway all the time? And all of the group were really, really positive and supportive. So we chaired that every day, and we still do chair that every day. Platform screen doors was an interesting one. We from a combination of SCADA logs and signalling logs, we could see small variations in the platform screen door performance, and that's been put in, and we've been running that for a couple of years as a very successful predict and prevent. As soon as they move away from an established characteristic, we get a maintenance intervention before we get the service failures. Train crew displacement is another area we've worked with MTR on as the company running the operators running the service. What we found was we would have, and this is a sort of a zoom in, an initial issue where we'd got quite substantial delay on the railway. Then the railway would recover, but an hour or two later, suddenly we'd have a secondary wave of delay because the drivers are now all displaced and we've got trains without drivers. So what we've put in place with MTR is a crew management tool that basically takes 6 different data sources, merges them together and gives a live version of exactly what's happening with the train crews against their rosters, which supports MTR enabled to be able to reform their schedules and their drivers to support recovery. So really big and important improvement to the railway.
This for me is cutting edge, Phil, because railways always grind to a halt after an incident, running out of crews who are all in the wrong place. And to have that, if you can preempt those delays and have a crew ready, it's all about keeping the trains moving. It's really good to see.
And what's been really good about that, our developer has been, because we're always in the control room, we're aligned with the operators, actually been sat next to the users, the train operator management, that are doing this and developing the system with them, so it's helpful for the operators. It works for the operators. Great. So I takeaway messages. I mean, the first thing, it's all about culture. Start early, have an operational mindset, and really drive out the improvements on the railway and think about how that whole railway will operate. One team every day of the week. We have massively good cooperation between all the different operators and suppliers. Absolutely essential, open, honest, transparent, and all in the right direction just to get that railway working. The stress testing was essential when we wrote that special timetable, and we really drove that system, and that really accelerated being revenue ready. The other thing that with that we have observers in the control centre. We need to be attuned with the operators, but we pull all the logs every day, and we get feedback from train operators, central operators, but we also strafe through all of the central logs each day to see what's happened in the background that didn't get reported but would or could have caused significant delays. And then we've done preemptive to sort of think about what our future service pattern will be and what we need to do to be ready for those service patterns.
So before we go to questions, I'm going to ask you one thing, which is a bit of a left field question. What's the one thing you would do differently with all the knowledge you currently have?
Oh, no, that's a really, I give a very straightforward answer to that. I think that the further you can get to the left-hand side of the V to the project, in thinking about what you want in terms of railway performance and getting that culture in, the quicker, the more effectively your railway is going to come into service, both in terms of the capacity and the performance and the robustness that you get. And too many times, as with this railway, I've ended up coming in further across, and I've spoken with various people, experts in the industry, really experienced people, and we think 60 to 70% of service performance issues could and should have been preemptive before service. They would have been evident at some point, and then you can get a much better entry to service.
So that's going to stray into the questions from one of the people that I've asked for questions in advance. Before we go there, I really want to emphasise to delegates at the conference and to people that watch this on the internet afterwards about the one team approach. So if you and I rewind 20 years when we started working together, Jubilee Northern Line, it was one team with tube lines and London Underground and Thales as a signalling supplier. If you fast forward to the Line 1 in Toronto, where you worked for Pete Tomlin and I, helping us with reliability and work cars, that was a one-team approach. We never got the contract out once. And if you now fast forward to the Elizabeth line, what you said and what Mark Weil said last year, you have to have a one-team approach with no contract on the table for you to achieve what you want to achieve. And you just demonstrated that again. And I don't know how many times we have to say that, Phil, to people about the one-team approach moving forward.
Yeah. Yeah, and you will have to do it sooner or later on the project. So if you get it in early, then you'll have a much more successful project.
Okay, good. So we're out of time, but I'm going to ask you a couple of quick answers. In typical fashion, Yusuf Komina is at the conference and is probably beaming as I say this. Rather than asking one question, asks two. So I'm going to lob them together for you. Throughout the migration and testing, to what extent, if any, did you have to deviate from the ConOps, and how did you buy buy-in? And it's kind of linked to the second one, which is to what extent did reliability improvements were they achieved, and what's the most difficult part of that? So ConOps and KPIs.
So starting with the deviate from the ConOps. Well, when we did that thrashing of the system in the December, we were and working with the operators, we were very transparent. There was no point. We had some very significant issues that were impacting our ability to run the system proving. So things like I've described, that domino effect that we had. So there was no point in us just every day having the same major failure modes. So we did actually use a lot of operational workarounds. So as we discovered a new failure mode, we'd actually work with the operators and we'd work around. It's an operational workaround, noting not acceptable for passenger service, but also in order for us to keep driving through and understanding more about the system, we couldn't just have the same failure modes. And the other thing is the KPIs. Well, we've had rigorous KPIs all the way from, we actually put them in before we ran the system proving. We were running off the testing that was being done to get a view for where the main failure modes were and how we needed to improve the railway. So
yes, this question was, how far did you achieve your targeted improvements? And what was the most difficult part of achieving that? I mean, did you meet your performance targets in terms of reliability at the end of this process?
So we ended up with extremely solid performance in the central areas. So the performance target was nominally 95% ppm. It's a performance measure on the railway for trains arriving at destination within 5 minutes. We were running quite a number of days, 98, 99%. We even managed 100. What we did find, and you won't be surprised, is when you got passengers on, those dipped down a bit. And the other thing, we got a lot of disruption from the Great Eastern and the Great Western. They've got freight trains and all manner of other things in there that put delays on the railway.
But that's real life, so you have to get used to it, and it's how you manage them. Just the other quick question before we finish, Phil. It wouldn't be the same without Walter Kineo, who you saw in the picture at the beginning asking a question. And Walter messaged me back and said, in terms of drilling down into the use of data for reliability growth, where do you think further improvements can be made? Is it real-time receipt, or is it AI analysis, or something else to take this to the next level?
As with always with Walter, it's a very good question. Thank you, Walter. Thank you. So I mean, in terms of the analysis with the data, I think you have to do it on two fronts. One is we had a really good relationship, Siemens, Alstom and Norbrems, so there was free sharing of data and information, logs and diagnostics, so we could really get to the bottom of root causes, and that was, again, working with all the teams, so we're really good. But the other big thing is we characterised the railway. And that's really important, because it's not just failure modes, it's things like getting the junctions to run more effectively for the flat junctions, so you get less conflict. And I think there is big opportunities with AI to do that sort of tune up, particularly on the overall railway performance and the relative movement of trains.
Particularly where you've got manual driving on both sides coming into the centre, and that variability you'll have at convergence points. Phil, we're out of time. Thank you for your time. Thank you for sharing this deck with us. It will be available to delegates afterwards, and we will put Phil's contact details onto the screen, which will be somewhere around here shortly, so you can email Phil directly. Phil, thank you ever so much. It's a real interesting, open heart surgery, as we said, and hopefully we'll see you in person next time. So I'm going to hand back to Bill and myself at the conference, which is all a bit weird. But thanks, Phil, and have a great vacation in Spain.
Can I just say thank you to everyone for listening, and I really would have liked to have been there. It looks like an amazing conference, loads of amazing people. At some point I have to balance my work and home life because I spend far too much out in control centres. Well, you're going to miss... So be lovely to come in a future year.
Well, I will toast you Thursday evening in the bar if that works.
Cool, thank you.
Thanks, have a good day, Phil. Thanks, goodbye. Yes. Over to you, Bill.